Okay, let's look at homework 4.9, problem number 10. Right? Alright, so it says that so a car is traveling at 100 kilometers per hour and hit the brake, and we want to stop within 70 meters. Alright, so let's do that. Alright, so it has a constant deceleration, so let's call it A0. So that's going to be a negative number, so maybe I should indicate that. So it's a negative deceleration, right? Then in order to find, say, velocity function, so let's call it v of t, right? Right, so acceleration or deceleration is the derivative of the velocity. So we can take the antiderivative of the acceleration or deceleration, a0, with respect to time. Right, so this is going to be a0 t, that's the antiderivative, plus some constant. Let's call it v0. Alright, but you can see that the v0 is the initial speed, so it's 100 kilometers per hour, and actually we have to convert it to so 100 kilometers per hour would be 100 kilometer is 100,000 meter, and 1 hour would be 3,600 seconds. So it's going to be meters per second, right? Let's see, we can simplify, so you can cancel that 2 zeros and 2 zeros and divide through by, say, 4, and that will be 9. Divide by 4, so it's at 250. Right, so it is 250 over 9. 250 over 9 meters per second. So we just convert the units to meter per second. All right, so so this would be v0. So we have this formula. So a0 we still don't know what it is. All right. But the v0 is, so it's going to be plus 250 over 9, right? So we have that. All right, so let's say this is the velocity. So we want to know when the car comes to a stop, complete stop. So the velocity becomes 0. So let's set that equal to 0. All right. So this will give you, we're going to solve for t. So subtract 250 over 9. So it's going to be a0t is equal to negative 250 over 9. Right? Then we can just divide through by a0. So divide through by a0. So t is going to be negative 250 over 9a0. Right? So this is when the car comes to a stop. Right? And by taking another antiderivative, we can get the position function. Let's call it the position function s of t. Right? So we take the antiderivative of the velocity function. So it's going to be antiderivative of a0t plus 250 over 9. Right? So this is the, we take the antiderivative of the velocity function. So you would get a0 over 2 t squared, so that's the antiderivative of a0t, and the antiderivative of 250 over 9t. Alright, so since initially we can take the position to be 0, so plus s0, but we can just take s0 to be 0. Right? So I'm not gonna even write that, so yeah, I'm gonna just erase this. All right, so this is the position function. All right, so we want this position at this time, we want this position to be 70 meters or less than 70 meters. All right, so we're gonna plug in, so S of t, which is negative 250 over 9a0 is going to be, all right, so just plug it in, so it's a0 over 2. Then you have to square this guy, so so it's a 200 negative sign square, it's gone, so you have a 250 squared, and you have a 9 squared, then you have a0 squared, right? So that's t squared there, right? Then you have plus 250 over 9, right? So the t is negative 250 over 9a0. Alright, so let's simplify that. So you can see that a0 on top and one of the a0 cancel out, and you can see that you're gonna have 250 squared over 9 squared a0 over 2, right, with the and a minus 250 squared over 9 squared a0. So this is going to be simply negative 250 over 250 squared, and 2 times 9 squared a0. Right, and we want this expression to be 70. Right, so we can solve for this. First step would be we can just multiply both sides by a0. Right, that way you get negative 250 squared over 2 times 9 squared is equal to 70 a0. Right, then we can just divide through by 70. Right, so a0 is going to be, so negative 250 squared over 2 times 9 squared, then times 70 here. Alright, so let's get this value. Alright, let's bring out a calculator. Alright, let's see, we need to compute, so 250 squared and divided by 2 times 9 squared times 70, right? And we just have to remember to put a negative sign. So this is negative, right, so this is negative about 5.51. Alright, so let's type this guy in. Alright, so let's put that answer. It was negative 5.51. Alright, let's check the answer. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.